Good evening, students. How are you all? Welcome to session 2 of pair of linear equations and two variables. I'm Kanika ma'am, your mathematics teacher. So yesterday also we had discussed the same topic and we started with the same. We've already learned a pair of linear equations and two variables in grade 9 where we were dealing with a single equation in two variables. So one equation and two unknown quantities we were dealing with. Now yesterday we started to learn a pair of linear equation in two variables where we were dealing with two linear equations in two variables, two linear equations and two unknown quantities. We also discussed this Akhila's example yesterday where she went to a village and she enjoyed the giant wheel ride and she also played the hoopla game. So this we discussed in the previous class where we had already formed equations of this situation where we were already knowing that Akhila took X number of rides and she played hoopla Y times. And it was also given to us in the question that Y is half of X. She played hoopla half the number of times she enjoyed the ride. And we were also knowing that 3 rupees was the cost of the ride and 4 rupees was the cost of hoopla. So we have 3x rupees for 3x rupees she has spent for rides and 4y rupees she has spent for hoopla, and in all she had spent 20 rupees. So all this we discussed yesterday. So this entire situation we learned how to represent this algebraically. That means how to represent this by two equations. Then we also discussed solution of an equation. Solution of an equation means, for example, if we take this equation 2x plus 3y is equal to 5, those values of x and y which are going to make LHS and RHS equal, they call solutions of the equation. Like in this case, we took an example x is equal to 1 and y equal to 1. So if we put x as 1 and y as 1, we are going to get LHS and RHS both 5. So we'll say x equal to 1 and y equal to 1 is solution of the equation. Also, we discussed another example here, x equal to 1 and y is equal to 7, where we had put these two numbers in the LHS and then we realized that the LHS is 23 and RHS is 5. That means LHS and RHS, they are not both equal. So we can say x equal to 1 and y equal to 7 is not a solution of the equation. And yet in yesterday's class, we also discussed in detail geometric meaning of solution. So geometrically, the solution means that the point 1, 1 lies on the line representing the equation and the point 1, 7 does not lie on it. This means that all the solutions for a particular equation, they are going to lie on the graph of that equation. And if we have, like in this case, we have 1, 7, that is not the solution of the equation. So this point 1, 7 is going to lie somewhere outside the line. So if you have a solution for a particular equation, it is going to lie on the line, and it is vice versa also. All the points which lie on the line, they're all solutions of the equation. Now we also discussed the general form for a pair of linear equations in two variables. That's a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0. Now, if we are dealing with a pair of linear equations and two variables, that means we are dealing with two linear equations. We are going to draw for one particular equation, if we draw the graph on the Cartesian plane, we'll get one line. And if we draw two linear equations, if we draw the graphs of two linear equations and two variables on a single Cartesian plane, we are going to get two lines. Now, those two lines can either be intersecting, they can be parallel also, they can be coincident also. Now, when the lines are intersecting, they have only one point in common. One point in common means that this particular point is going to satisfy both the equations simultaneously. So that's the case of unique solution. When the lines are coincident, we have infinite number of points in common. That's the case of infinite solution. And when the lines are parallel, we don't have any point in common. That's the case of no solution. Now please notice for a set of equations, if we have solution, and doesn't matter if it's unique or infinite, that doesn't matter, but then if we have solution, we will say that the set of equations is consistent. And if we don't have solution, like in this case, we'll say that the set of equations is inconsistent. Now in yesterday's class, we had also learnt how to draw the graphs of linear equations in two variables. Like in this case, we had drawn graph and we realized that the lines are intersecting. Here the point of intersection is solution of the equations. So this is going to satisfy both the equations simultaneously. Now students, it is not always practically possible to draw the graphs every time and to figure out whether the lines are intersecting, parallel or coincident. So we have another method of actually checking whether the set of equations is consistent or inconsistent. So if we have a pair of equations, like this is the standard form given to us, and the following situations arise. So this general form for writing a pair of linear equations in two variables, it's given by a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0. If we have the ratios a1 upon a2, b1 upon b2, they are unequal, then we will say that the set of equations is consistent. And in this case, we have unique solution. Unique solution means exactly one solution. And if we have a1 upon a2 equal to b1 upon b2 equal to c1 upon c2, so that is the case of dependent solutions, consistent and dependent. So that's the case of infinite solutions. We have infinite solutions. And if we have a1 upon a2 equal to b1 upon b2 not equal to c1 upon c2, in this case the pair of equations is inconsistent. Inconsistent means no solution. Now if we have unique solution in this case, we will say that the lines are intersecting, only one point in common. And if we have all the ratios same, we know that the set of equations is consistent and they have infinite solutions. Infinite solutions means that the lines are coincident. And if we have a1 upon a2 equal to b1 upon b2 not equal to c1 upon c2, that's the case of no solution. The set of equations is inconsistent. No solution means no point in common. That's the case of parallel lines. So always it's not necessary to draw the graph. You can figure out the consistency by checking these ratios. So I'm going to explain you using a question here. On comparing the ratios a1 upon a2, b1 upon b2 and c1 upon c2, find out whether the following pair of linear equations are consistent or inconsistent. So we have this equation 3x plus 2y equal to 5, 2x minus 3y equal to 7. Now whenever you write equations here, please make sure that the constant term here, the constant terms should either be on the left hand side, both of them, or on the right hand side. That is just to avoid any confusion. So just check whether you have the constant terms both on the left hand side or the right hand side. That's only to avoid mistakes. Now we are going to take the first equation and we'll compare it with a1x plus b1y equal to c1. So we have a1 as 3, b1 2, and then we have c1 5. Then we are going to compare this one with a2x plus b2y equal to c2. So we have a2 as 2, b2 minus 3 and c2 as 7. Now we have got all these values. Now we'll check the ratios. So a1 upon a2 here is 3 upon 2, b1 upon b2 here is 2 upon minus 3. So we can write this as minus 2 upon 3 because we never leave the denominators negative. As we can see that a1 upon a2 is not equal to b1 upon b2. So that's the case of unique solution. The set of equations is consistent and it has exactly one solution. Now in this case, you need not check c1 upon c2. That's not required. If you get a1 upon a2 not equal to b1 upon b2, you can straight away conclude that the set of equations is consistent and it has unique solution. Now coming to the second example here, again we have two equations. We have to check the consistency here. So I'm going to compare this with a1x plus b1y equal to c1. So from here we'll get a1 equal to 2, B1 equal to -3, C1 equal to 8. And this I'm going to compare with A2x plus B2y is equal to C2. So I'll get A2 as 4, B2 as -6 and C2 as 9. Now let us check the ratios. We have A1 upon A2 is equal to 2 upon 4, that is 1 by 2. B1 upon B2 equal to -3 upon -6, that's 1 by 2. And C1 upon C2 is equal to 8 upon 9. Now we can see that these two are same, but this is different. So we have A1 upon A2 equal to B1 upon B2, not equal to C1 upon C2. So this is the case of no solution. That means the set of equations is inconsistent. So no solution. So if you draw the graphs of these two equations on the Cartesian plane, you will get parallel lines. No point in common, no solution. That means you're going to get parallel lines in this case. Students, I hope you've all understood till here. Okay, so let's discuss the next one. We have 5x minus 3y is equal to 11, and then we have minus 10x plus 6y equal to minus 22. We are going to compare this with a1x plus b1y is equal to c1. Now, if we compare this, we'll get a1 as 5, b1 minus 3, c1 here is 11. Now, this we are going to take, we'll compare it with a2x plus b2y is equal to c2. So, we will get a2 minus 10, b2 6, c2 minus 22. Now, a1 upon a2 is 5 upon minus 10, that's minus 1 by 2. b1 upon b2 here is minus 3 upon 6, that's again minus 1 by 2. And c1 upon c2 is 11 upon minus 22, that is minus 1 by 2. So, as we can see here, all the ratios, they are same. All of them are equal to minus 1 by 2. So, that's the case of infinite solutions. We have a1 upon a2 equal to b1 upon b2 equal to c1 upon c2. That's the case of infinite solutions. So, yes, the set of equations is consistent. Yes, we have solution and we have infinite solutions in this case. So, if you draw the graph of linear equations, these two linear equations on a Cartesian plane, you are going to get coincident lines. Now, here we have question from NCERT. On comparing the ratios a1 upon a2, b1 upon b2 and c1 upon c2, find out whether the lines representing the following pair of linear equations intersect at a point, are parallel or coincident. That means you need to check whether it's a unique solution, no solution or infinite solutions. Now, if the lines intersect at a point, there's one point in common. That's the case of unique solution. If the lines, if you have the lines parallel, no point in common, that's the case of no solution. So, and when the lines are coincident, that's the case of infinite solutions. So, we are going to take these two equations. The first step is we are going to compare this with a1x plus b1y plus c1 equal to 0. So, we'll get a1 as 5, b1 minus 4, c1 8. Now, we'll compare this with a2x plus b2y plus c2 equal to 0. So, we will get a2 as 7, b2 as 6 and c2 as minus 9. Now, let's take the ratios. We'll get a1 upon a2 as 5 upon 7. Then we'll get b1 upon b2 as minus 4 upon 6. We can also simplify this and write it as minus 2 by 3. So, here as we can see, a1 upon a2 is not equal to b1 upon b2. These two are not equal. So, we'll say that this is the case of unique solution. If we draw graphs of these two equations on a Cartesian plane, we will get one point in common. That means the lines would be intersecting. Intersecting lines, that means here we have unique solution. So, the following pair of equations intersect at a point. Intersecting at a particular point means that's the case of unique solution. a1 upon a2 not equal to b1 upon b2. Now, let us discuss this one. Here also we are going to first compare this with a1x plus b1y plus c1 equal to 0. So we'll get a1 here as 9, b1 3, c1 12. We'll compare this with a2x plus b2y plus c2 equal to 0. We will get a2 as 18, b2 6 and c2 24. Now here we have a1 upon a2 as 9 upon 18, that's 1 by 2. b1 upon b2 as 3 upon 6, that's again 1 by 2. c1 upon c2, that's 12 upon 24, this is also 1 by 2. So we can see all of these ratios, they are same. We have a1 upon a2 equal to b1 upon b2 equal to c1 upon c2. So this is the case of infinite solutions. So that's the case of coincident lines. So if you draw graphs of these two linear equations on a Cartesian plane, you're going to get coincident lines. Now let's discuss this one. We have a1x plus b1y plus c1 equal to 0. So by comparing these two, we'll get a1 as 6, b1 minus 3, c1 10. Now this is a2x plus b2y plus c2 is equal to 0. So from here we get a2 as 2, b2 minus 1 and c2 9. Now we have a1 upon a2 here as 6 upon 2. This is 6 upon 2, that you will get 3. b1 upon b2 as minus 3 upon minus 1, that you will get 3 again. And c1 upon c2 is 10 upon 9. We cannot simplify this. We'll stop here. So these two are same, but this one is different. So we can see a1 upon a2 equal to b1 upon b2, not equal to c1 upon c2. So this is the case of no solution. That means if you draw graphs of these two equations on the Cartesian plane, you will get no point in common. No point in common means that these two lines would be parallel. So this is the case of parallel lines. Now here also we have to check the consistency of the equation. So we are going to compare this with a1x plus b1y is equal to c1. Children, please notice these are the questions which we are doing from NCERT. And then we are going to get here a1 as 2, b1 minus 3 and c1 8. And if we compare this with a2x plus b2y equal to c2, we'll get a2 as 4, b2 as minus 6 and c2 as 9. Now let us take the ratios. We'll get a1 upon a2 as 2 upon 4, that's 1 by 2. b1 upon b2 as minus 3 upon minus 6, that's again 1 by 2. And c1 upon c2 is equal to 8 upon 9. So here as we can see that a1 upon a2 equal to b1 upon b2, not equal to c1 upon c2. So that's the case of no solution. So the set of equations, if you draw them on the Cartesian plane, you will draw the graph of them on the Cartesian plane, you will get parallel lines. Now let us discuss this one. We have a1x plus b1y equal to c1. Here a1 is 3 by 2, b1 is 5 upon 3 and c1 is 7. If we compare this with a2x plus b2y is equal to c2, we'll get a2 as 9, b2 as minus 10 and c2 as 14. So we have a1 upon a2, that is 3 upon 2 upon 9. So how we are going to write this? We'll write this as 3 upon 2 into 1 by 9. So if we divide this, we are going to multiply this by reciprocal of the denominator. So we'll get here 1 upon 6. Now let's take b1 upon b2. We will get 5 upon 3 upon minus 10. That's 5 upon 3 into minus 1 by 10. We'll take reciprocal of the denominator. And we'll multiply here. We are going to take the numerator and we'll multiply it by reciprocal of the denominator. So we will get here minus 1 by 6. Now please observe here, A1 upon A2 and B1 upon B2, they are not equal. They are not equal, so that's the case of unique solution. So we will say that the given equations, they have exactly one point in common. They have exactly one solution. That's the case of unique solution. Now let us discuss something different here. Okay. For which value of k does the pair of equations below has unique solution? So here we don't know one of the coefficients here. Like the coefficient of y is unknown to us. We have to solve for that, and we have to solve it in such a way that this set of equations has unique solution. So for unique solution, we'll first compare this with a1x plus b1y plus c1 equal to 0. So we can see here a1 is 4, b1 is k, that's unknown, c1 is 8. Now if we compare this one with a2x plus b2y plus c2, we'll get here a2 as 2, b2 as 2 and c2 again as 2. Okay. Now for which value of k does the pair of equations below has unique solution? For unique solution, a1 upon a2 is not equal to b1 upon b2. That means 4 upon 2. a1 upon a2 is actually 4 upon 2. 4 upon 2 is not equal to b1 upon b2. That is k upon 2. So now we are going to simplify this. We'll cancel out this k and we will get we'll cancel out this 2 and we'll get k not equal to 4. That means k can take any value except 4. K not equal to 4 means k can be any value except 4 for this set of equations to have unique solution. So you can write here k can take any value except 4. K not equal to 4 is the condition for this set of equations to have unique solution. Now we have a similar question here. For what values of k will the following pair of linear equations have infinitely many solutions? So here we have a1x plus b1y plus c1 equal to 0. So see here k is unknown to us. We have to find out k in such a way that this set of equations, they have infinitely many solutions. So what is the condition for infinitely many solutions? We have a1 upon a2 equal to b1 upon b2 equal to c1 upon c2 with all the ratios equal. So we have here a1 as k, b1 3 and c1 is equal to minus k minus 3. Minus times of k minus 3. You can write it as minus k plus 3 also. And then we have a2 as 12. This is a2, b2 as k again and c2 as minus k. So now for infinitely many solutions, we should have a1 upon a2 equal to b1 upon b2 equal to c1 upon c2. That is k upon 12 equal to 3 upon k equal to minus k plus 3 upon minus k. So we are going to take first two ratios and we'll solve for k. So we have k upon 12 is equal to 3 upon k. If we cross multiply this, we will get k square is equal to 36. So if k square is 36, we can either take k as 6 or minus 6. Now let us take these two ratios. So we have 3 upon k and then we have minus k plus 3 over minus k. So we can cancel out these k's and then minus we can take here. This will get multiplied. We'll get minus 3 is equal to minus k plus 3. K we will take on this side and minus 3 we'll take on this side. So we have positive k is equal to 3 plus 3. So finally we have k is equal to 6. Now if we solve these two ratios, we are getting k as positive 6. And if we solve the first two ratios, we are getting k as 6 or minus 6. So since we have k is equal to 6 here, common to both of them, so we can say finally k is equal to 6 will make the given set of equations consistent and they are going to have infinitely many solutions. Since we want infinite solutions, for that we need k is equal to 6, since that is satisfying both the conditions here, both the ratios here. Now children, let us discuss the next one. Given the linear equations 2x plus 3y minus 8 equal to 0, write another linear equation in two variables such that the geometric representation of the pair so formed is intersecting lines, coincident lines and parallel lines. Now please notice 2x plus 3y minus 8 is equal to 0 is given to us. We have to form another equation such that the given equations, they are forming intersecting lines. Intersecting lines means that's the case of unique solutions. That's the case of unique solution. That means only one point in common. One point in common, unique solution. That means algebraically a1 upon a2 we should have not equal to b1 upon b2. So form another equation so that a1 upon a2 is not equal to b1 upon b2. So there is no specific answer in this case. You can just find out as per your choice. Just make sure that a1 upon a2 is not equal to b1 upon b2. So you can just write it as 3x plus 2y minus 5 is equal to 0. You can have different answers also. Make sure that this condition is satisfied. So I can just write this as the answer of first part. Now in case of parallel lines means no point in common. No point in common, that's the case of no solution. Algebraically, this is a1 upon a2 equal to b1 upon b2, not equal to c1 upon c2. Now, keeping this in mind, you write such an equation such that a1 upon a2 and b1 upon b2, they're equal, but not equal to c1 upon c2. So you can write from here as 2x plus 3y minus 7 is equal to 0. So you will get a1 upon a2 as 1, b1 upon b2 as 1, c1 upon c2 as 8 upon 7. So this condition will be satisfied. That's the case of parallel lines. So I can write this as the second answer. So children, as I told you earlier, you can have different answers also. Make sure that this condition is satisfied. Now comes the third part, that is coincident lines. Coincident lines, that means we must have a1 upon a2 equal to b1 upon b2 equal to c1 upon c2. So we have to make the ratio same. So what we can do in this case, take this equation given to you and multiply it with any number. You can multiply it with 5, with 10, anything as per your choice. Like in this case, I'm multiplying this throughout by 10. So I'll get 20x plus 30y minus 80 is equal to 0. So we'll get all the ratios here as 1 by 10. Just see, all the ratios, they are 1 by 10. So we can say that in this case, we have infinite solutions. So that's the case of coincident lines. So I can write this one as answer of third part. Students, I hope you've all understood this. Now coming to this one. For which value of k will the following pair of linear equations have no solution? So here we know that the set of equations is inconsistent. That's the case of no solution. And we have to figure out the value of k so that we have no solution. As we can see here, a1 is 3, b1 is 1 and c1 is 1. a1x plus b1y equal to c1. This is a1x plus this is a2x plus b2y equal to c2. So a2 here is 2k minus 1, b2 is equal to k minus 1 and c2 is equal to 2k plus 1. Now we have no solution, that means a1 upon a2 equal to b1 upon b2 not equal to c1 upon c2. So a1 upon a2 here is 3 upon 2k minus 1, b1 upon b2 is 1 upon k minus 1 and c1 upon c2 is 1 upon 2k plus 1. Now we need to solve for k. We'll take these two equations. We'll multiply this here. We are going to actually cross multiply. So we have 3k minus 3 is equal to 2k minus 1. Let us now solve for k. We'll take this on the other side and this we'll take towards the right hand side. So we will get here 3k minus 2k is equal to minus 1 plus 3. So we will get here k is equal to 2. Now since we have got k is equal to 2, Just to be on safer side, we're going to put 2 here and we'll check whether these two ratios, they're coming out to be unequal. So we will get here 1 upon k minus 1 not equal to 1 upon 2k plus 1. So we have here k is equal to 2. So if you put here k is equal to a1 upon here we are going to get here k is equal to 2. If we put here, we'll get 1 upon 2 minus 1 not equal to 1 upon 2 into 2 plus 1. So this is 1 not equal to 1 upon 5. So yes, k is equal to 2 is satisfying this condition also. If you put k is equal to 2 here, just check here, you will get 3 upon 2 minus 2 into 2 minus 1, that's actually 3. 3 upon 3, that's 1. You will also get here 1 upon 2 minus 1, that's 1 upon 1, that's 1. So you will get these two ratios same, and if you put k is equal to 2 and you will compare these two, you will get these two ratios unequal. This would be 1 and this would be 1 upon 5. They're unequal. So finally, in this case, if we take k is equal to 2, we will get a1 upon a2 equal to b1 upon b2 not equal to c1 upon c2. So k is equal to 2 will make the set of equations inconsistent. They will have no solution. So children, we have already discussed how to solve pair of linear equations in two variables on the graph. We draw a graph of both the equations, and wherever the point of intersection is, that is solution of that particular set of equations. Now this was the graphical method. Now we are going to learn algebraic method of solving pair of linear equations in two variables, and here we have three methods. We have substitution method, we have elimination method, and cross multiplication method. So in today's class, we are going to discuss in detail substitution method. Now here we have set of equations x plus y is equal to 5. Let us name this as equation 1, and 2x minus 3y is equal to 4. So this we are going to name as equation 2. In substitution method, we are going to pick up any one of these two equations. Any one, that's your choice, whatever you find easy as per the question. So I'm going to pick up the first equation here, and here I will write y in terms of x. You can also write x in terms of y, that doesn't matter, that totally depends on you. Whatever you find easy as per the question. So I'm going to take the first equation and I will write y in terms of x. That means I will take this x on the other side and I will get y is equal to 5 minus x. Now this value of y I'm going to pick up and I'll put it in the second equation. Please don't put it back in the first equation. You will land up nowhere. You have to put this in the second equation. So y you have to replace by 5 minus x. So we are going to put y is equal to 5 minus x in the second equation. So you will get here 2x minus 3 times of 5 minus x is equal to 4. Now this 3 will multiply inside, we'll get 2x minus 15 plus 3x is equal to 4. And when we combine these two, we'll get 5x. And 15 we can take on the other side, we'll get 4 plus 15 here. And finally we'll get 5x is equal to 19. So x is 19 upon 5. Now once we get this x as 19 upon 5, we are going to pick up this value and we'll put it in any of the equations. Equation 1, 2 or 3, that's our choice. We'll put it in any one of the equations and then we will solve for the corresponding value of y. So I'm going to pick it up and I'm going to put it here in the third equation. So put x is equal to 19 upon 5 in the third equation. We'll get y is equal to 5 minus 19 upon 5. We'll take the LCM. We'll get here 5 here and 25 minus 19 here. So finally we have y as 6 upon 5. So we have got the values of x and y both. I'm repeating this right from the beginning. In case of substitution method, we take any one of the equations, that's our choice, and we either write y in terms of x or x in terms of y. That's also our choice, whatever we find easy as per the question. Here in this case, I've taken the first equation and I've written y in terms of x. So I've written y as 5 minus x. Now this y is equal to 5 minus x, I'm going to put it in the second equation. Please notice, do not put this back in the first equation. You will land up nowhere. You have to put this in the second equation now. Now you will get y is equal to 5 minus x. Replace this y by 5 minus x. You will get 2x minus 3 times of 5 minus x equal to 4. 3, you're going to take inside the bracket. You will get minus 15 plus 3x. And these terms will remain the same. Now we'll combine the like terms. We'll get 2x plus 3x, that is 5x. 15, we are going to take on the other side. This will become plus 15. So we have 5x is equal to 19 here. And finally, x is 19 upon 5. Now we've got the value of x. We are going to take this value of x and we'll put it either in the first equation or second or the third one. Any one of these, that's okay. You can put it anywhere. In any case, you will get the same result. So here in this case, I've taken x is equal to 19 upon 5 and I've put this in the third equation. So I've got y is equal to 5 minus 19 upon 5. Then I've taken the LCM, that's 5, and I've got 25 minus 19 in the numerator. Finally here y is 6 upon 5. So we have x and y both. X 19 by 5, y 6 by 5. To understand this better, let us discuss one more question. Solve the following pair of linear equations by substitution method. So this is the first equation. This is the second equation. Seems to be quite easy. Okay. So I'm going to take here the second equation and I will write x in terms of y. So y I'm going to take on the other side. I'll get x is equal to 4 plus y. Now this x is equal to 4 plus y, I'm going to put it in the first equation. So put x is equal to 4 plus y in the first equation. So we'll get 4 plus y is equal to 14. I have replaced this x by 4 plus y. That's how I've got here 4 plus y equal to 14. Now 4 we are going to take on the other side and then these two we can combine. We'll get 2y. 14 minus 4, that's actually 10. So we have 2y is equal to 10. So y is 5. So y is equal to 5. Now let us put y is equal to 5 in any one of the equations. We can put it here also in this third one. So we'll get x is equal to 4 plus y. Y is 5 actually. So x is 9. So we have got x is equal to 9 and y is equal to 5. Just to be on safer side, you can just put these values here in the first and the second equation and you can check whether the LHS and RHS, they're coming out to be same. So that's just for checking whether your values are correct. So in this case, we have x is equal to 9 and y is equal to 5. Let's discuss one more question. Here we have s minus t is equal to 3. Let's name this as the first equation. S upon 3 plus t upon 2 is equal to 6. That is the second equation. Now it is difficult to deal with the denominators here. So I'm going to take the LCM so that I get rid of the denominators. I'll show you how. In the second equation, I'm going to take the LCM, that is 6. We'll get here 2s plus 3t is equal to 6. 6 will go on the other side and will get multiplied. So we have 2s plus 3t is equal to 36. Now this second equation we have put in this form in order to get rid of the denominator to make our work easy. Now in this case, I'm going to deal with this third equation instead of the second one. And this first one I'm writing as it is. There's no change. Now I'll be dealing with the first and the third equations. Now we'll solve these two as usual as we do it for substitution method. So I'm going to take the first equation and I will write s in terms of t. I'll take this t on the other side and I will get s as 3 plus t. Now this s is equal to 3 plus t. I will put this in the third equation. So I'll replace this s by 3 plus t. So put s is equal to 3 plus t in the third equation. We'll get 2 times of 3 plus t plus 3t is equal to 36. 2 we'll take inside. We'll get 6 plus 2t plus 3t is equal to 36. We'll combine these two, we'll get 5t. 6 will go on the other side, will get subtracted. So we'll get 36 minus 6, that is 30. And then we will get t as 6. Now we have got t as 6. We are going to put this here. So we have s is equal to 3 plus t that we had already solved. We are going to replace t by 6. So let us put here 6. We'll get s is equal to 3 plus 6. Finally, we have s as 9. So we have s is equal to 9, and then we have already calculated t is equal to 6. So these are solutions. Alright children, so I am winding up here. In the next class, we will be discussing substitution method in detail. Also, we will be doing word problems of the same. Thank you children.